Okay, so we talked about the unit circle, and so we're going to build on that. It's pretty foundational for what we're going to be doing. So you want to make sure that you have an understanding of where these values all come from, right? And so remember the unit circle. It's just to recap real quick. It's a circle where the radius is 1, right? So no matter where you draw this radius, it's going to be 1, right? And depending on the angle here, like 30 degrees, or you might say pi over 6 if you're doing radians, no matter what angle you pick, you always end up with a triangle where the radius is 1. And so if you think about this triangle as an x and a y value, right, that'll give you the coordinate point on the circle. And so in this case, it's square root of 3 over 2 comma 1/2. That's the length of the x value, the x side, right? And the length of the y value, or the y side. Okay, so square root of 3 over 2 and 1/2. And that just comes from, I mean, you can use the Pythagorean theorem to verify that. Okay, and so that's the unit circle, at least really briefly. So today, this morning at least, I want to just use the unit circle to answer some questions, find some function values. Okay, so here we have secant of pi over 6. So if I picture that on the unit circle, pi over 6 is here at 30 degrees, and that point we just talked about, square root of 3 over 2 comma 1/2. Okay, and so if I'm looking for secant, I have to remember what secant is, right? Remember, secant is the same thing as 1 over cosine. Secant is the same as 1 over cosine. And so if I think about it like that, what I'm looking for is the reciprocal of cosine of 30 degrees. And maybe remember, right? Whenever we think about sine and cosine, we think about cosine of an angle as an x value and sine of an angle as the y value. And so if we're looking for cosine, we're looking for the x value here, or the reciprocal of the x value, because we want the secant. So the reciprocal of that, 2 over the square root of 3. Okay. You could think about it like 1 over the square root of 3 over 2. But remember, when you divide by a fraction, you're really multiplying by its reciprocal. And so that gets you back to the square root of 2, or 2 over the square root of 3, right? So either way you want to think about it, as a reciprocal right away, or as 1 over the fraction. Then when you figure it out, you end up with the reciprocal. Either way, it works. But let's talk about also rationalizing the denominator. Okay, so we can't leave that square root of 3 on the bottom. It's considered improper. And so to handle that, I will multiply the top and the bottom by the square root of 3, whatever this happens to be, the square root of whatever. So the top becomes 2 the square root of 3. The bottom becomes square root of 3 times square root of 3. Now you can think about that a bunch of different ways, but the answer there is 3. You could think about this as the square root of 9, of course, which would give you 3. You can think about that as the square root of 3 squared, in which case those would cancel out and leave you with 3, right? So different ways you can think about it. Just really depends on how you see it. Let me make sure that it doesn't say equals. Okay. So different ways, either way, 2 the square root of 3 over 3 would be the value I'm looking for. Okay, let's find the exact value of tangent of pi over 4. Okay, so I'm going to picture the circle here. Pi over 4 is 45 degrees, so we're right here. And that point there, square root of 2 over 2, square root of 2 over 2. Right, remember, this all just comes from the unit circle. You want to learn that circle, memorize it, use all the tips that we went over last time. Okay. All right, and so remember, tangent is the same thing as y over x. Same thing as y over x. So I can take the y value, put it over the x value, and that'll give me tangent. So the y value over the x value, this is uglier than it needs to be. because there's so many options for dealing with this. Hopefully, right, the easiest way to deal with this one is to recognize right away that this is something over itself. Anything divided by itself is going to be 1, usually, right? Usually. If you prefer to multiply by the reciprocal, you could do that, of course. Right, when you just take the denominator, flip it over, and make it into a multiplication problem. But when you do that, you get 2 the square root of 2 over 2 the square root of 2. We're still the same thing over itself. So again, you get to 1. So however you want to look at it, the answer is going to be 1 there. And it comes from putting the y value over the x value. Okay, let's do another one like this. Cosecant of negative 7 pi over 4. Okay, so we got a little bit going on here. Remember, cosecant is the reciprocal of sine. So sine of negative 7 pi over 4. Okay, so if I find sine of negative 7 pi over 4, then I can just find its reciprocal and I'm good to go. All right, so let's think about the unit circle. And here's where it's a good idea to understand the pattern, right? Because if you think about it, here's pi over 4. Here's 2 pi over 4, which of course is just pi over 2. 3 pi over 4. 4 pi over 4, which of course is just pi. And so on, right? So it's every 45 degrees. Well, that's going from, counterclockwise. If we go clockwise, we get the negative. So if I go this way, that's negative pi over 4, negative 2 pi over 4, or negative pi over 2, negative 3 pi over 4, negative pi, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4. We're back to the first quadrant. Okay, so I just went in reverse. So that's one way you can deal with it. That might be a little bit more challenging, but that's something you could do. What I would usually do is off to the side somewhere, I would try to find what we call a coterminal angle. Okay, and a coterminal angle just means the same angle, but with a different value. So if you look at pi over 4 and negative 7 pi over 4, these two are different in the sense that they're two different values, but they're the same in that they're in the same position. You're right here. Okay, and so to find a coterminal angle, you just add rotations. Now, how you add those rotations depends on if you're dealing with degrees or radians. Okay, and so we're dealing with radians, so we're going to add the equivalent of 360 degrees, which would be 2 pi. Okay, so I would say negative 7 pi over 4 plus 2 pi would give me a coterminal angle, right? I'm adding a rotation. I'm trying to make this negative into a positive. Okay, well, 2 pi is the same thing as 8 pi over 4. Where did I get that? Well, I want it to have a denominator of 4 because negative 7 pi over 4. And the only way I can get that denominator is to multiply the current value by 4. So that's where I got 8. So 8 pi over 4. If I add negative 7 pi over 4 plus 8 pi over 4, I get 1 pi over 4. That's the coterminal angle there. Okay, so sure, I did this thing where I changed the angle to an easier to use value, knowing that these two things will be the same now. No matter what, I'll get the same value because those angles are the same in the same position on the circle. Okay, and so let's just work with this right here. Let's go back to pi over 4. At pi over 4, we know that the point is square root of 2 over 2, comma, the square root of 2 over 2. So I need the reciprocal of the y value. Remember, sine of theta is the y value. So I need the reciprocal of the y value. So square root of 2 over 2 flipped over. Okay, let's rationalize the denominator. Remember, we can't leave that square root of 2 in the bottom. That's going to give me 2, the square root of 2. That's going to give me 2, right? Remember, you could think about that as you squaring it, which of course would just mean those cancel out. Or you could think about that as the square root of 4, which of course is just 2. Either way. Okay, and then what? These 2's cancel out to leave you with the square root of 2. And that's it, square root of 2. Okay, so let's move on to a different type of problem. Very similar, but a different type. So find the exact values of the remaining functions of theta. So here we have tangent of theta is 12 over 5. Okay, so the remaining ones would be, of course, sine, cosine, cosecant, secant, and cotangent. Okay, but they give us some information. Okay, so tangent of theta is 12 over 5 with theta being in quadrant 3. Okay, so where's quadrant 3? Maybe you remember your quadrants, right? 1 going counterclockwise, 2. Here's 3, and of course this would be 4. Okay, so it's in quadrant 3. So what I'll do is say, all right, it's over here somewhere. I'll make a triangle. Of course, make sure that your triangle is made with the x-axis, right? So it should be between the radius, right? If you picture a circle here, the radius and the x-axis. That'll form your right triangle. All right, and so we know that tangent is 12 over 5. We also know, if we think back, that tangent is y over x. So we're given a y value and an x value. We're given the y value to be 12 and the x value to be 5. Okay, and so to find sine, cosine, you have to remember, of course, what all these mean. Remember, sine is y, cosine is x, cosecant is the reciprocal of sine, so 1 over y. Secant is the reciprocal of cosine, so 1 over x. Cotangent, reciprocal of tangent, so x over y. Okay, so those are all the things we're looking for. And so I do have, of course, an x value and a y value, so I can actually fill some of these in. Let me do that. Let's see. The one that says 1 over y. Oh, actually, you know what? I'm realizing now. Let me not say it this way, because that's only true whenever we know the radius to be 1, but we don't know what that radius is yet. Okay, so instead of thinking about it as x's and y's, okay, although it's good to set up the triangle originally, what we need to do is think about this in terms of opposite sides and the hypotenuse, or adjacent sides and the hypotenuse, and so on. Okay, and so here's my angle. The opposite side would be the side directly across from it, so 12 in this case. Opposite side is 12. The adjacent side is the side that's touching that angle that's not the hypotenuse. So the adjacent side is 5. We have to find the hypotenuse. So to find the hypotenuse, we would do the Pythagorean theorem. Okay, so a squared plus b squared equals c squared. 5 squared plus 12 squared is equal to the unknown c squared. Okay, so that's going to be 25 plus 144 equals c squared. 169 is equal to c squared. And then the square root of 169 is 13. So this is going to be 13. The hypotenuse is 13. Okay, and so now let's go ahead and start filling in our values. So for sine, we have opposite over the hypotenuse. For cosine, we have adjacent over hypotenuse. Cosecant is the reciprocal of sine, so flip 12 over 13 over. Secant is the reciprocal of cosine, so 5 over 13 flipped over. And then cotangent would be tangent flipped over, and tangent was given to us in the original problem here. 12 over 5, so we'll flip that over to 5 over 12. So there we go. That's what I was trying to find. Well, sort of. So I'm not quite done. I'm close though. The next thing to recognize is if we're in the third quadrant, then my X's and my Y's would be, depend on positive and negative, right? If sine corresponds to Y values, the Y value down here is a negative. So my sine should be negative, and my cosecant, right? Because they're based on the same thing. My cosine would also be negative, right? Because this point has a negative X value. So cosine would be negative and secant because, again, they're based on the same thing. Okay, tangent was positive, so cotangent is also going to be positive. All right, there we go. Here's the last question on this page here. We have a point for -5. And it's on the terminal side of theta. Find the exact value. Okay, so the way this question is worded is to make it seem different from the other problems, but it's really the same thing. We know that 1, 2, 3, 4, 1, 2, 3, 4, 5. That's a point down here. They're saying, okay, there's your triangle, where this side is 4 and this side is 5. We'll say -5, so remember it's a negative Y value. Okay, and so from there, they want to find the exact values of the remaining 6 trig functions, or the 6 trig functions. So we need to find the hypotenuse. Okay, let's find the hypotenuse. (16 plus 25 is equal to c squared. 41 equals c squared. So c is the square root of 41. By the way, we know when we're solving equations, there's technically a positive and a negative here. But when we are dealing with a side length, it's always going to be positive, right? We're not dealing with negative lengths. So we just ignore the negative there. All right, so 4, -5, and then square root of 41. Sine, opposite over hypotenuse. Okay, cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Cosecant, sine flipped over. Secant, cosine flipped over. And then cotangent is tangent flipped over. Okay, so the bottom 4 are great. We do need to fix these top 2 because we need to get that square root out of the denominator. I have to rationalize it. So I'm going to multiply the top and the bottom by the square root of 41. Same thing here. By now, I think you know that's just going to be 41. 41. All right, that's the 6 trig functions. All right, and so I think that's about all we have time for. Oh, wait, no, we have time for this last one here. Okay, good. Let's talk about this last one. I forgot about that one. I do want to go over this real quick. It says approximate the given values to 3 decimal places. And the reason why I want to go over this one is because This is a trick question that you might come across. Okay, it's meant to be pretty simple, where you just type in, let me see if I can share. I don't think you can see that. Let me try to fix that real quick. Okay. So here you just type it in. So here I'm using tangent of negative 2.01. Okay, but notice there's no degree symbol here. There's a degree symbol on this one, not on this one. Okay, that means that we're in radians. Okay, that's why this is a trick question. This is a radians problem because there's no little circle up here. So I'll switch this over to radians. There we go. My answer would be 2.1285. Well, 3 decimal places, so 128 will come in 9. Okay, so that's a radians question, right? All right, this one right here says cotangent of 3 degrees. So first of all, cotangent is the same thing as the reciprocal of finding tangent of 3 degrees. So let me find tangent of 3 degrees, switch that over to degrees, tangent of 3. And then find its reciprocal. Not sure how to do that on here. Let's see. You could just do 1 divided by tangent of 3. There you go. That gives me 19.081. Okay, so just be careful. That's the whole point of this, right? Be careful. There you have radians. Here you have degrees. All right, that'll do it for this section.